in a world without storage. Sounds like I'm about to make some movie announcement. All right, here's what we're going to talk about. We are going to talk about storage that you mount inside of an operating system. And we're going to talk about storage that is like a remote storage system that you just access, like an FTP server. You just access it, you dump files on it, you pull files off of it, but you don't mount it inside it. You don't mount it like a disk. You just dump files on it or you pull files off of it, but you don't like stick it into your operating system. It doesn't show up as a drive letter or some other device on your system. It's just something you talk to through an API usually. And then we're going to talk about two of the database services, the big ones basically, which is the RDS service, which is relational database service, and then DynamoDB, which is Amazon's big like flagship NoSQL service. If we're going to talk about storage, there's really only three types. Block and file are the storage types that get mounted into your operating system. One of them is local disks, and the other one is a server that's just offering up what looks like to be disks, but it's actually layer 7 like application. Object storage is a little different because object storage is more like Google Drive or like Dropbox. It's like out on somebody else's system. You can, again, push files and pull files and all that stuff, but you don't really mount that. Don't get me wrong, you could replicate a copy of it, but it's not really like a disk drive, which is what block storage is kind of. Block storage is like a disk drive. File storage is like a disk drive, but over the network. So we're going to learn about block storage first, because that's the easiest concept. So in block storage, what happens is that we take a disk, we put these arbitrary like breakpoints on there, 4K, 8K, 16K, that kind of thing. And what we do is we break this disk into like little blocks. And so if I need to write an 8K file and my blocks are 4K, I'm going to take 2 4K blocks because that makes 8, right? If I want to do 9K, I got to do 3 4K blocks because I need 12. If that makes any sense. So block storage is what these virtual machines use to store like operating system information, log files, like all the stuff that we use like disks for. This is what this is. We know block storage because you've got a hard drive inside of your laptop. You got a hard drive inside of your desktop, and that's block storage. You plug a USB drive directly into your system, that's block storage. It's got a file system on it. You write files to it. They take up a certain size. It's finite. You understand how that works. Amazon has 2 different types of block storage. Instant storage, where it's basically like using the storage that's on the physical host that's hosting the virtual machine. And I just want you to be clear on this. If that system crashes and you're using instant storage, that hard drive is deleted. So most people don't use instant storage at all. Instead, they use a service called the Elastic Block Storage System. Elastic Block Store is technically the name. And this is a permanent volume that exists like on it's almost like a dedicated storage service that shares its disks. Excuse me. That's nice. Little hiccup. With the EC2 virtual machine. And that EC2 virtual machine mounts that disk as if it's locally attached storage. So EBS is for permanent storage, excuse me. And instant storage is for temporary storage. Now, don't get me wrong, instant storage is really fast, but it comes at the price of being temporary. Oh, wow. Did I just get hiccups somehow magically while talking? That's fabulous. Can't wait to watch this video again later. That's going to be fun. So EBS volumes, by the way, are permanent. So do know that EBS volumes, by the way, can also get very fast, but just to say this, instant storage is free if it's present. It's not always present. EBS volumes always cost you money. They're never free. But just to say this, it is best practice to not use instant storage at all. Okay, just stick with EBS. Besides, you can't snapshot or backup instant storage. You can snapshot or backup EBS. Okay. So just know that you can actually take running live incremental backups of EBS if you need to. There it is. That's great. I'm so glad I can be self-entertained by my own hiccups. Okay, so then what is the key thing that, just to check this, what's the key difference between instant storage and EBS volumes? What is the key difference? Because they're both block storage. One's super fast, one can also be fast. One's not free, one's not free. What's the other difference? Good. Yeah. Remember, if you accidentally lose an operating system, like if the virtual machine crashes or you decide to stop it, any data on those instance stores is gone. So persistence is the difference. Okay, so now let's compare this against object storage. So block storage is no different than just adding a disk in. Object storage, that's great. Object storage is when you upload a file, you've got some metadata about that file, like is it a video file, is it a JavaScript file, etc. And you got a key, like a name, for example, like it's maybe called like my favorite cat video of all time, dot, whatever, right? Maybe Terry, I got scared already, and that's why I got hiccups. That's funny. I don't think I've had hiccups for like years. It's funny. So just know that you can take that data and upload it to a remote storage system called S3. To show you what this looks like in the console, I logged myself out. Let's get back in. Sorry, I keep trying to put myself on mute, but the timing on it is a little odd. So here's S3, and notice that there's a bunch of names here. I usually put like weird names in here because everything has to be globally unique across the entire customer base. So it's kind of shocking sometimes. Like, it's like DevOps Cyber Club is the club I ran. Dead Hot Chili Peppers was just some random name, right? If we look in here, there's a file in here, a test file. So this looks like a file system. It's really not. I can't put this on my local system, but I can upload the file. I can download it. So like, I can come in here and look at its metadata, right? I didn't actually put any metadata in here. So it's listed as just like a standard file, just because it's got a file extension on it. This always, by the way, gets some kind of web-enabled URL, but just notice that this system is not public, so nobody can get to this file. But that's all this is. This is just like Google Drive. It's a file dump. And it really does a really good job of scaling to like millions of files. Back in 2014, I used this object storage system called S3. It's the simple storage service. I actually used this storage to run a video company, that made north of $60 million a year in revenue. It was all consistent of an object storage. Now, the simple storage service is the service that provides this for AWS. Now, you store objects in buckets. You set some permissions for those objects. And by the way, they can be public, they can be not public. It's up to you. And you can actually use hot or cold storage classes to define whether you want this to be super performant, super fast, or whether you want it to go into archive mode and not be accessible at all unless you call it back up. Now there's a bunch of different storage classes here. There's standard infrequent access. I don't know why they shortened that. It should say infrequent access, standard infrequent access. There's one zone infrequent access, and these are all storage classes that you can access the files directly. This is also true for intelligent tiering. Notice that they're all green, right? Now, if it were me, I would have changed these two to like red or something. But Glacier and Glacier Deep Archive, you cannot actually access the files. You can see that they're there, but you have to restore them, because I want you to think of Glacier and Glacier Deep Archive as archival services. which they are. So, just know that these are the coldest flavors of storage inside of S3. And you use particularly deep archive when you want to put a file away and just let it disappear for 6 months. You don't want to touch it. So here's a quick knowledge check, and I'm going to answer this question for you because this is a hard concept to kind of wrap around. When you want to store a data that is infrequently accessed, but it must be immediately available when needed, just to make sure I'm very clear about this, this cannot be Glacier. Glacier is an archival service. If you put something in Glacier, it's gone, right? But I just want to say this is that when they use the words infrequently access, they are talking typically about that storage class. So Chris, what you put here as far as standard infrequent access is dead on the mark. The only thing I didn't really explain is that intelligent tiering, which is why I always stop at this first question. Intelligent tiering is when you don't know what your access pattern is, but you want to benefit from colder storage classes. So what you do is you just tell Amazon, hey, can you just use machine learning to learn what my access patterns are? And if you see that a file is not being accessed, can you just move it to colder storage? That's what intelligent tiering is. Intelligent tiering allows AWS to automatically classify and move your storage around, and you can set the upper and minimum, like you can set boundaries for that. But if you put something in intelligent tiering and it isn't accessed for 30 days, it's going to move it to infrequent access. If it isn't accessed another 60 days, it's going to put it into Glacier. If it's in Glacier and it's an intelligent tiering and someone accesses it or tries to access it, it's going to move it out of Glacier and immediately into standard S3. So just want to make sure that was clear. Intelligent tiering allows you to automatically move your files around based on access patterns. Okay, so we talked about block storage, which is like hard drives directly attached to your system. We talked about object storage, which is a remote storage system a la Google Drive, OneDrive, whatever. What if you want to share objects like disk drives from one server to another server, but you want to make them look like they belong on that server, like they're local? Sorry, I'm trying to get myself to yawn to see if that'll help. File storage works a little differently in that a file is shared, but here's the funny thing. This is built to be accessed by like dozens, if not thousands of concurrent boxes at the same time. So this isn't like a hard drive. This is like an application, like a file sharing application that is sharing like drive letters that you can mount across the network. This is like network storage. Now, Amazon's Elastic File System, EFS, is the primary service for this. There's also another one called FSX, right? And usually it's spelled like this. So there's 4 different flavors of it. There's FSX for Windows, FSX for Lustre, FSX for ONTAP, and FSX for OpenZFS. OpenZFS just came out like, I want to say early December. So this is designed to share files with thousands of servers if needed. So what's the difference between block storage and file storage? Well, from the operating system that's using it, doesn't look like much difference. The performance of block storage is way better because file storage is actually coming from a remote server. And remember, object storage can't be mounted inside of a file system, so its performance is the worst out of all of the options, but it can handle a larger spread of files, usually better. Okay, so just remember that. Any questions about the various storage types? Okay. And let's talk about database, which is basically just a data application, right? Let's talk about that next. Now, there's two types of databases. Well, that's a weird statement. There's like tons of types of databases, but there's two broad, like possible types. There's a relational database, which has a strong schema and has a lot of structure to it and basically uses rows and columns. And then there's a non-relational database, which basically also in a sense uses tables, rows, and columns, but is a little less strict about how those like blobs of data or documents are kind of like fielded and related. A relational database actually needs to maintain like isolation between the fields because there's a relationship between the various tables that may make up a database. In a non-relational database, there may be no relationship between the documents or blobs of data other than that they are of a similar type, but not all the attributes need to be there. So that, a non-relational database has a very flexible schema. Whereas a relational database tends to have a less flexible schema than a non-relational. Now, if you need a relational database, which is usually pretty good for transactional processing and resolves contention in a very what's called acidic way, right? You're going to use the relational database service. This relational database service, by the way, is going to abstract away the process of you running the operating system for your database. And it comes in these 5 flavors: MS SQL, Oracle, MariaDB, MySQL, Postgres, and then a sub flavor that Amazon came up with of Postgres and MySQL called Aurora. And Aurora is like a cloud native version of Postgres and MySQL. So if you need to run a database and it needs to be relational and you don't want to roll your own, you're going to use the relational database service. One word of note that most people aren't aware of is that Oracle and MS SQL cannot be run in any kind of cluster or, synchronization mode on RDS. You have to roll your own Oracle cluster on EC2 or your own MS SQL cluster in order to get like log shipping or that kind of thing working. Now, I mentioned before that Aurora is the cloud version of MySQL and Postgres. If you take the exact same data set and run it in standard Postgres versus Aurora Postgres, it'll be like 3 times faster. With MySQL, I think it's 5, if I remember correctly. Amazon has done some really cool stuff with how they do reads and writes in storage. And so they've learned how to maximize or parallelize, if you will, the queries in Aurora. So even though it looks like MySQL and it looks like Postgres, it operates much faster. So remember, Aurora, by the way, is the subset of RDS. It's not its own product. So don't let them fool you. They'll talk about Aurora as if it's own product. It's a subset of RDS. It lives inside of RDS, inside the console. All right, food for thought. One of the employees at the coffee shop has an idea for a new inventory management system. They think this should be a text file in S3. Do you agree with using a single text file inside of S3 as an inventory management system? And if so, why or why not? So Chris, what's the biggest problem with using a flat file, by the way? Why is that such a big issue, a big deal or a big issue? What's the one thing that a flat file is not going to resolve that a database will? That's right. That's actually well said. It's going to resolve contention, right? Or multiple access at the same time. So it's really not going to work to use the file inside S3 for your inventory management system, like an Excel file as an example. Now let's talk then about non-relational databases, right? So here, what you're looking for is you look for a key. And by the way, that could be a number, but typically keys in non-relational databases are things that you're going to search on, like, I don't know, someone's name, like maybe their full name. Maybe you do a composite key where it's their full name plus their birthday. So just know that you can set up the kind of keys that you want to make your data easily findable. And by the way, you don't have to pull out everything in there. You could actually do either server side or client side filtering and just ask for the specific data that you want instead of just pulling back everything that's in the table. So DynamoDB is the primary service for this. And just to mention this service is wicked fast because in the Prime Day event that was in 2019, I want to say like there were like 7.11 trillion requests that came over to AWS. I think it was like it lasted 48 hours, right? At its peak, they were handling 45 million requests per second. 45 million requests per second. So DynamoDB is quite the workhorse. In addition to having this awesome NoSQL service that works really simply, they do actually have a database migration service. So if you're looking for someone to help you with your migration process, so there's actually a service. There's a server migration service, there's an application discovery service, there's a data center migration service, there's a database migration service. So just know that Amazon has a bunch of migration services that can help, but it does have a database migration service that allows you to put an agent on the database and either one time or continuously just sync it up with AWS. So just know it's a really good service. There's also, by the way, a schema conversion tool that goes with this that will help you to convert it to a different database type if you need to. Just depends on the database. All right, quick knowledge check. For each scenario, should you use Amazon RDS or Amazon DynamoDB? So if I want to store data in a relational database, which should I use, RDS or DynamoDB? Good, Chris. I saw that you put RDS down. I didn't see any other guesses. And that's correct, right? If you want to run a completely serverless database, are you going to use RDS or are you going to use DynamoDB? Now, to clarify that, because I might be clear to everybody, DynamoDB, you cannot log into the operating system at all. RDS, you can see that there's an operating system, but you also can't log into the operating system, but you at least know when you start it what the size of the operating system is. Like, yeah, it's hard to explain. But truly, DynamoDB is the only serverless option where you don't have to worry about the servers at all. When you start an RDS database, you actually have to pick one of the EC2 instance sizes, and that's the size of your database. You can upsize it, don't get me wrong, but with DynamoDB, you don't worry about that at all. You just tell AWS what you want as far as performance, and it will just scale the thing. You won't see that in any way, shape, or form. Okay, number 3, if you want to store a database in a key value database, what service do you have to use? Yeah, you're still using DynamoDB for this, right? DynamoDB is one of the flagship NoSQL database services. That's what it's used for. All right, what if you want to use SQL in order to organize data? Oh, never mind. I just accidentally hit that ahead of time. We're going to use RDS for that. Woohoo! Yeah, sorry. Jumped the gun there. All right, what if you want to scale up to 10 trillion requests per day? Out of the box, which service is going to handle that, RDS or DynamoDB? Good. Storing data in an Amazon Aurora database, is Aurora a subset of DynamoDB or is it a subset of RDS? Good. Yeah, subset of RDS. Excellent. Now, remember, I told you that this class only gets you to 60 to 80% of the knowledge you need to pass the exam. This is one of those areas that is surprisingly meaningful because it does show up on the exam, is that you do need to know that Redshift is the data warehousing service for AWS. You just got to keep that memorized. Oh, it's the data warehousing service. Okay, cool. I didn't know. And then Amazon's got a MongoDB compatible service called DocumentDB. It's got a Cassandra compatible service called KeyStore. It's got a managed Kafka service. So if you're looking for Kafka and you don't want to roll your own, which most of my friends are moving over to that. If you want a Neo4j database, they've got Amazon Neptune. Oh, actually, it's listed right there. Sorry. They've got a Ledger database. They've got managed blockchain. They've got Elasticsearch. They've got like a Solar clone. If it's an open, if you want Memcache or Redis, they've got it. If you want ActiveMQ, which I know is not a database, but Kafka and ActiveMQ, right, are like queue services, streaming services. They've got that stuff as well. So just know that it's there. Oh, hey, look at that. Also remember that the DynamoDB accelerator, also known as DAX, DAX, is a read-only cache to improve DynamoDB from milliseconds to microsecond response times. So, yeah. All right, knowledge check. All right. So which Amazon S3 storage classes are optimized for archival data? Which of these two letters belong to archival? Good. Saw some good answers there. B and D, Glacier and Glacier Deep Archive. That's exactly right. Which option is true about Amazon EBS volumes and Amazon EFS file systems? So take a look at this for a second. What's true here? I don't know that I explained this actually, so it might be hard to really figure out unless you already know. EBS volumes, which is block storage, right? They are actually only exist in a single availability zone because virtual machines only exist in a single availability zone. EFS is meant to be mounted by multiple virtual machines regardless of what availability zone they're in. So EFS is region wide. So A is the answer, is that EBS is going to store data in a single availability zone, whereas EFS is going to store data across multiple availability zones. So good question is there, just to make sure we explain that, right? All right, customer wants to store data in an object storage service. Which AWS service is the object storage service? That's what this is asking. All right, the name of the simple storage service, or object storage, sorry, is the simple storage service. So S3 is the object store service inside of AWS. Okay, which of these statements actually describes Amazon DynamoDB? That's right. It's a serverless key value database service. That is exactly correct. Which service is used to query and analyze data across a data warehouse? What did I say was Amazon's premier data warehousing service? That's right. It's got a funky name. It's called Redshift. Good. Neptune, by the way, is the graph database. Just make sure that's clear, Chris. All right. In this module, we learned about some AWS storage and services and resources. We learned about basically the different storage classes for S3. And we talked just briefly about the two general types of database services, namely the relational database service versus DynamoDB. Okay. Questions about module 5, about either the storage systems, either file, block, or object, or about the database systems themselves. I know it's only been an hour since we came back, but I need to just go get a glass of water really quick. So why don't we take a break until 2:15? So it'll be about 9 minutes. And I promise we'll take another break later. But let's come back in about 9 minutes and we'll continue on with this module around security. I just need to get rid of my hiccups really quick. I'm still having them. So I'll be back in just a second. Okay, thank you.